Hello friends, welcome to engineering tutorial. So in today's video we are going to discuss how to convert signed binary numbers expressed in 2's complement form into decimal form. So this is the first question. So it is given to convert the given two signed binary numbers which are expressed in 2's complement form into decimal form. So the first one is 001 000 11. The second one is 110 11101. So here also the process is same. First we have to assign the weights. So these are 8-bit numbers. So 7, 6, 5, 4, 3, 2, 1, 0. Okay, so we'll write the first number, which is 0, 0, 1, 000, then 1, 1. So the first step here also similar to 1's complement method. First we have to examine the sign bit. So here the sign bit is 0. So it is a positive number. Here also similar to 1's complement, the MSB bit or the sign bit, that is associated with a negative sign, a negative weight. Okay, so this sign bit is 0, so the negative weight does not play any role. So directly we will go for the other thing. So okay, the sign bit is attached with a negative weight. Okay, negative sign or negative weight. So whatever it is minus 2 to the power 7. But here it is 0, so it will not play any role. So directly the weight positions which will play a role are the bit position 1 and 2 to the power 5, the bit position 1 and 2 to the power 1, and bit position 1 and 2 to the power 0. So it is, the decimal value is 1 into 2 to the power 5 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Okay, so it is equal to 32 plus 2 plus 1, which is equal to 35 or plus 35. Okay, so it is plus 35. Now for the other signed binary number, let us copy this bit position. So here we have copied the bit position. Now the second signed binary number is 1101, then 110 11101. Okay, two more ones, then again 0 1. So here the first step again, examination of the sign bit. So here we see that the sign bit is 1. So obviously it is a negative number. Okay, and it is attached a negative weight. That is, in order to calculate the decimal value, we will attach a negative sign to the sign bit. Okay, this. So the process will be 1 into 2 to the power 7 with a negative sign attached, and the remaining we have the bit positions, 1 bit positions, we have plus sign. 1 into 2 to the power 6 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 0. Up to this it is the same as 1s complement. Now in 1s complement, what we do for negative sign binary numbers, to convert them into decimal form, we add a plus 1 at last. But here in 2s complement we don't do it. We do not add plus 1 at last. In 2s complement, let me write it here, we do not add 1 at the last step. For negative sign numbers, whereas in 1s complement we add a plus 1 at last to convert them into decimal. For negative signed binary numbers, only for negative signed binary numbers this step is applicable, not for positive ones. In 1s complement we add a plus 1 at last for 1s complement, and in 2s complement we don't do anything, we just keep it as it is. So the result is the decimal value is equal to this much, so it is minus 128 plus 64 plus 16 plus 8 plus 4 plus 1. So it is equal to minus 128 plus 64 plus 16, 80, 88, 98, 93. So it is equal to minus 35. So here it is minus 35, and the previous signed binary number, the positive one, it was plus 35. So this signed binary number is the 2s complement of this binary number. Okay, this one is the 2s complement of this binary number. Okay, because it is plus 35 and here it is minus 35. For 1s complement, it is a bit easy to identify bit patterns for 1s complement numbers. Just by looking at them we can say, okay, this is the 1s complement of this. But for 2s complement it is a bit difficult because we have to add a 1 to the LSB of the 1s complement. First we have to take the 1s complement of that binary number, and then we have to add a 1 to the LSB, and the resultant is the 2s complement. So for 2s complement it is a bit difficult to identify bit patterns visually just by looking, whereas for 1s complement it is comparatively easy. So as you can see, this is signed binary numbers minus 35 and plus 35, which were expressed in 2s complement form with this bit pattern, the 2s complement of this. Okay, so this is the thing.